All right, everybody, welcome to part one of the weathering or breakdown lab. And I think it's a good idea, as we do the three things, the weathering, erosion, and deposition, I think it's a good idea that we constantly remind ourselves what these mean. So let's remember, weathering means breakdown. How do things under surface break down? So we got a couple of different experiments that we're going to do that usually this is a pretty fun part of class. People always dig doing these little experiments. I'm sorry that we have to do them on YouTube this year. So let's do it either way. Well, we've got two beakers with about 250 milliliters of water in them. They've been sitting for a while, so the temperature should be the same, and that's important, but I can always do a little bit of this like mad scientist thing where you pour back and forth, like that does something. But that should at least ensure that the water in each is the same. So I'm not pulling any tricks here. Equal volumes of water, the same exact beaker. And the thing that's going to be different, the variable we want to test in this lab, is what if we take one Alka-Seltzer tablet, or Equate brand effervescent tablet, one dissolving tablet, and put it into a beaker whole, time how long it takes to dissolve. And then we'll take another one, and I'm going to break it into 10-ish pieces and see how long that one takes to dissolve. The thing we're testing in this lab, and I should ask it as a question, but if every time I take this tablet and I break it, I'm not going to do it over the screen, or over the keyboard, I mean. But if I break it, I've just created two new surfaces. So if you think about what part of this tablet will be touching the water when it goes in, it's only the outside, the surface. And every time I break it, I create brand new surfaces. So I'm going to take this one and trying to not make a mess, break it into about 10 pieces. And then I'll do it as two separate trials. It's too much to try to do at once. We'll time how long this one takes to dissolve. We'll time how long the whole one takes to dissolve. And we'll say that's it for experiment one. Sound good? All right. This lab says whole first, so let's do it that way. And I got my handy dandy stopwatch here. Yes, I do. All right. Ready? Go. And stop. All right. So my time on the whole tablet was 37.63 seconds. You want to call it 37.6? That's fine with me. All right. That's how long it took a whole tablet to dissolve. Next, same setup, but crushed. About 10 pieces of Equate brand effervescent tablet. And we'll put it through the same chemical reaction, see which one dissolves faster. All right. Ready. Go. Chemical reaction going there. It's dissolving away. And we'll stop. So the crushed, or the broken one, 30.49 seconds. That's it. So what it's meant to show us, I guess, is left for you to determine. But what happened when we created more surface area? Now you're calling how you want to do all this. If you want to do all the experiments first on YouTube, and then do questions, you can. Or if you, it might not be a terrible idea to do experiment, question, and so on. But these three questions go with that experiment that we just did. So what was the difference in time mathematically? When you break the tablet into pieces, what property are you changing? We created more surface area. And then how did it affect the reaction rate? using data. I want to see a number here. No number here, no points. All right, that's it. One experiment done so far for weathering or breakdown of rock under surface. Thanks for tuning in.